Unsupervised image-to-image translation networks. Given an input image in one domain, our goal is to translate the input image to a corresponding image in a different domain. The problem can be studied in two settings. In the supervised setting, we have pairs of corresponding images in the training dataset, which tells us how exactly one image is translated to another. In the unsupervised setting, we only have two datasets of images. No pairs of corresponding images exist. The unsupervised setting poses a harder learning problem. However, training data collection is easier in this setting. From a probabilistic point of view, the unsupervised setting is a problem of estimating the joint distribution of images in different domains by using samples from the marginal distributions. This is an ill-posed problem. Without additional assumptions, there are infinitely many solutions. We made the shared latent space assumption. Specifically, we assume that given any pair of corresponding images in the two domains, there exists a shared latent space Z and a pair of encoding functions E1 and E2 so that the two images can be mapped to the same latent code. And there also exists a pair of generation functions G1 and G2 that can map the latent code back to the two images. With this assumption, it means that if we can learn E1, E2, G1, and G2 from training data, then we can solve the unsupervised image-to-image translation problem. During training, we don't have corresponding images, but using E1, G2, and an adversarial discriminator, we can map a daytime image to a nighttime image. However, this nighttime image could be an arbitrary nighttime image. It may not correspond to the daytime image. To relate the two images, we further introduce a weight-sharing constraint to couple the functions. This weight-sharing constraint limits the network capacity and encourages a pair of corresponding images to be mapped to the same latent code for image translation. Results: day to night translation. Snowy to summery translation. Sunny to rainy translation. Real to synthetic translation. Cat species translation. Dog breed translation.